Hey everyone, thanks for joining us for the webinar today, a macro view on microservices. As you can see, it's being brought to you by CloudBees, Levvel, and Red Hat together. This is going to be a great discussion from these few companies, on how you can approach microservices. So just a few things up top. I want to let everyone know that we are recording this session and it will be sent out to you within the next few days. It takes a little bit of editing, so just a little bit of time. You can ask questions. We are setting aside some time at the end to answer questions, so please feel free at any time you think of something. Don't feel like it may not get asked, so therefore it's not worth asking. Just go right ahead and ask it, and if we can't get to it on the air, we can always get to you offline later. So we have a few speakers today. I'm going to let them introduce themselves, but to get us started, I would like to introduce our opening speaker, Jeremy Davis from Red Hat. Jeremy.
Hey, good afternoon. Jeremy Davis. I'm a principal solutions architect at Red Hat, and I specialize in our application development stack. Internally to Red Hat, I am the co-manager of our microservices community of practice, and I have been tightly involved in this space for the past several years. And prior to joining Red Hat, I wrote lots of software for a number of different companies across a number of different industries. And since joining Red Hat, I've worked with customers in financial services, telco, cable, logistics, manufacturing, retail. So I've covered a lot of different areas. And thanks for joining today. And so I will hand it over to Keith LaForce.
Hi, everyone. Thank you for taking the time to listen to Buffy and I. My name is Keith LaForce. I am a director at Levvel. I am currently working as a consultant. We work in a lot of different industries. We work in many Fortune 500 companies, and I've worked with them through their process of moving to microservices. And I will be speaking in just a moment on an introduction to microservices. But first, I will let Buffy introduce herself, and then I will step back in.
Thank you. Good morning. I'm Buffy Gresh, Director of Worldwide Business Value Consulting here at CloudBees. My background is in development and architecture, mostly in end-user computing for many years. I've been doing business value consulting for about 6 years now. And for those not familiar with CloudBees, we're the innovators, creators, and maintainers of Jenkins. We're providing enterprise-level service and solutions for companies that are driving automated CI/CD. What I do as part of our customer success program is my team works with customers and even prospects to quantify the realized or the projected value of driving automated CI/CD. So we get nice insight into hundreds of Fortune 1000 companies at different stages of CI/CD maturity. So today I'll be sharing some insights into the business value. I'll pass it back to Keith.
Thank you, Buffy. Jeremy, if you can you move to the next couple of slides? Thank you. All right, so the first thing we're going to talk about today is microservices at a high level. 2 more slides, Jeremy. All right, thank you. All right, so as I said, my name is Keith LaForce. I currently work at Levvel, which is a consulting firm that specializes in digital transformation, as well as a few other things. But today the topic is microservices, so we're going to talk about what does it take to create a successful microservices implementation, and ultimately what are the steps to get there. So Levvel has seen an increase over the past few years in a few different topics: platform as a service, DevOps, and ultimately microservices. You've probably heard of all these topics, but if you're not quite sure what they are, you've kind of at least been pretending so people think you know what the topics are. When clients come to Levvel, they want to understand what microservices are, how to implement them successfully, but really their root question is, how do I increase velocity for my feature development in software, and how do I reduce the cost of getting that software produced? So today's webinar is going to focus on answering those questions. I'm going to let Jeremy and Buffy go into additional detail on platform as a service and DevOps. But at a high level, we utilize platform as a service to reduce the cost of deploying and maintaining our infrastructure. And this can be anything from an on-prem data center to a cloud solution to a hybrid cloud solution. DevOps is a set of philosophies, best practices, and tools to increase an organization's ability to deliver software. These two core concepts are critical to the successful implementation of microservices, and that's definitely the message that we want to get across today. It's going to be all but impossible to be successful in microservices if you don't have a great DevOps story or a great platform as a service story. These two things together will allow you to not only rapidly deploy code, but rapidly deploy your infrastructure as well. Next slide. So I'm going to go into more detail in just a second on what exactly microservices are, but the first thing I want to talk about is what necessitates the need for this transition to microservices. Why is everyone talking about it? Levvel has worked with a number of clients with the problems that you see listed here in the presentation. I'm assuming that at least some of these, if not all of these, look familiar to all of you. When you're dealing with limited releases per year, that can be very cumbersome, not only to your software development process, but also to your customers. When you're doing 4 releases a year and a bug is introduced in Q1, does it require weeks or if not months to get a bug fix out to your clients? And what are the pain points that cause them and ultimately may cause you to lose them as a customer? When you can't deliver rapidly, it costs your business money and ultimately, again, makes your customers unhappy. I think part of the reason for this is just in today's world of Facebook, Google, Amazon, a lot of your customers, they interact with these larger organizations through these websites, and they get used to a certain mindset of how software is delivered. They believe that updates should be given, if not weekly, then on a daily basis kind of thing. So in order to keep those customers happy, as businesses, we have to start moving in that direction as well, and ultimately just increase the velocity at which we can deliver software. Next slide. All right, so now let's get down to kind of the nitty-gritty. So let's talk about what microservices are. So for those who aren't familiar, microservices is a paradigm shift in how software has been developed in recent years. In the traditional enterprise and most non-enterprise development shops, software is written as one large unit or block. All the features in the application are written, deployed, and tested as a large unit. There's a number of advantages to this and a reason that people have been doing this for so long. Most software developers understand this pattern. It's been the de facto standard for years. It's how they are taught and mentored to create software. Secondly, it's easier to think about, not only for your developers, but for your business analysts and your board and your CEO. It's just easier for everyone to think about, okay, we have this one application, we are doing a release today, and that has created, that has included X number of features. Finally, it's easier to test and deploy this single unit, which we'll call the monolithic architecture. In a traditional CI/CD pipeline, you can create one pipeline for deploying this application, no matter the true size of it. So even if you have your software running on a cluster of 20 Linux servers, it's still easier to think about in testing and deploying because it's still all one unit. Microservices takes this concept of a monolithic application, and it actually states that the features should be broken up, delivered independently as individual services. We might have a service for user authentication, we might have a service for managing orders, or we might even have extremely small services such as currency conversion calculation. There are many reasons to break up a monolithic application, but the primary motivator is to increase the speed at which features are delivered and ultimately reduce the cost of that delivery. An application as large as seen in many of the Fortune 500 companies are really hard to modify without extensive regression testing. So when you think about an application with billions of lines of code, if you make a small change to that code, it can have drastic impacts in places that you weren't aware. So you are required to do extensive regression testing before every release, and this is ultimately what's driving your limited number of releases per year and ultimately your ability to deliver to the client. Next slide. So one thing I want to emphasize today now that we've talked about what microservices are, is, should I even move to microservices? So I never recommend to clients when I'm interacting with them to start out with microservices. And what I mean by that is, if a client comes to me and they're building a new greenfield application, I almost never recommend that they start out with microservices, even though that seems to be what people are moving towards in general. And the reason I recommend against that is the cost of starting microservices can be cost prohibitive. The complexity of these products ultimately necessitate the need for microservices, but when you're first getting started, you need to start getting customers onboarded, you need to start getting features out there, and the time it takes to get all your microservices configured could ultimately run you out of business before you even get started. So that's why generally I'll recommend starting with a monolithic application and then later on moving to microservices once funding is there and available. So if we take a look at some of the larger organizations like Netflix and Twitter, they have hundreds and hundreds of microservices. If you think about your current monolithic application and the troubles you have with deployments and CI/CD, if you think about multiplying that hundreds of times, you can kind of start to see the scale of the problem and why you wouldn't want to start there. That being said, the next piece that we want to talk about is, okay, I've got an existing monolithic application. I'm trying to determine if I should move to microservices. Generally, what I recommend to clients as a first step is to start building a business case for that. Let's start looking at what are our current costs today, figuring out what's driving those costs, and ultimately make the decision of, will microservices actually solve that problem? So if you're questioning today whether you should move to microservices, you need to start by building that business case and trying to determine what is the true dollar value of that transition. Even estimates are okay for an initial discussion. I mean, we're not going to be able to generate exact numbers on cost saving, but if you can at least get a ballpark and you know that it's a negative $1 million, you know it's probably not a good time to make that transition. As a smaller gut check, just something along the way, you'll know you're ready to at least start thinking about microservices once you've reached a point where even minor changes to features can be a Herculean task, where if I want to make one small change, I know it's going to be 3 months down the road before clients see it. At that point, it's time to start thinking about this transition. Next slide. All right, so we've talked about what microservices are. We've talked about how you should determine if you're ready to make the transition. And we've kind of touched on the complexity required to be successful with microservices. Now that, let's just assume you've made the decision to move forward with microservices. Let's talk about how to do that. There are 3 ingredients that are required to be successful for microservices: organizational design, technology architecture, and DevOps capability. For DevOps capability, I'm lumping CI/CD and PaaS underneath that umbrella. And again, Buffy and Jeremy are going to talk about that in more detail later. So let's focus on the first 2. Organizational design is if not the most important, it's definitely tied for the most important change required for you to be successful with microservices. If your culture is in such a state that delivering features quickly is not ingrained in the culture, you're not going to be successful. Let me give you an example of that. I was working with one of the top 5 banks, and they were discussing how to move to microservices. They currently had 94 environments that they worked with, and they did 3 releases per year for their software. When I was in discussions with the client, they kept focusing on, well, we only want to release every 2 months. Like, we want to move from 3 months to 2 months. At that point, their organization is not aligned with the true benefit and concept of microservices. Moving to deployment every 2 months does not necessitate the need for transition to microservices, because ultimately you're going to end up breaking your application into a couple of monoliths rather than true microservices. And at that point, it's somewhat of a wasted effort as far as thinking about microservices. So that's one question you need to think about as you move forward: is my organization ready to move to something that can move quickly? Are my business analysts ready and understand the requirement that we're going to be delivering features not only monthly, but every week or every day, depending on what your goals are? The second piece that I want to talk about is technology architecture. Next slide. All right, so we kind of touched base on this a little bit already. We talked about as a greenfield development effort, it usually does not make sense to move to microservices. So let's talk about transforming existing monolithic applications. So when transforming an existing monolithic application, there are a few things that you need to think about. And really, this comes down to planning. I love agile development as much as the next engineer, but planning for microservices takes time. You can't just assume I'm going to start an agile process and we're going to be successful with microservices. You need to start planning the decomposition of your application out before we can really figure out what your goals are for microservices. So this is things like, what is the typical service size I should shoot for? Do we want hundreds of services, or do we want tens of services? How are we going to handle breaking up the database schema? How are we going to handle communication between these services? These are all pieces that you need to start thinking about and planning before you kind of move forward with the actual implementation. Once you've kind of made decisions on these questions, then it's time to start thinking, okay, what's the next step? Typically what I recommend to clients for this initial piece is to start with the prototype. Let's start with a new feature that you're trying to develop. Let's make sure that it's somewhat encapsulated in and of itself, and let's figure out the pattern to interact with our existing monolith. Because we're not going to just flip a switch one day and move to microservices. We're going to start creating services, and we're going to start transitioning services one at a time. And by the end of the process, we'll have eventually converted our entire monolith to a set of services. But you have to start somewhere, so let's start with something isolated, easy to think about, and ultimately set ourselves up for success. Next slide. All right, so the last thing we need to think about is, what is a deployment unit for a microservice? So one of the bigger challenges of delivering software quickly is setting up the CI/CD pipeline and creating a process that allows us to be successful in that regard. Microservices is no different, but instead of dealing with less than 10 pipelines, we're dealing with potentially hundreds of pipelines. So your DevOps engineers are going to become even more critical for the success of this transition. So the first step, again, in regards to thinking about what the processes are, is let's also think about what is a deployment unit. How do we want to set up these pipelines? Do we want to have a staging environment? Do we want to have a development environment? How do we get our developers creating these microservices on our local machines? And there's a number of tools that help in the transition for this. And again, those decisions need to be made up front before we can kind of start moving forward. So when deploying a microservice, there's a few things we can think about. And one thing I typically highlight to clients is, that the new thing that it's not completely new, but a lot of people are talking about is Docker containers. So when we think about Docker containers and microservices, those two things just work hand in hand. But I want to emphasize that Docker containers are not the only answer. We can think about deploying microservices as WAR files. We can think about deploying them as any other package that you might have, whether that's an NPM package or a Rails module. There's a number of ways we can do it. So don't get caught in the mindset of, we have to work with Docker and we have to do it a certain way. Again, I say that just to caution people, because I don't want to change, you don't necessarily want to change your entire culture and what typical tools you work with. But again, Docker is a great tool, and Jeremy's going to talk a little bit about the tools that are available via PaaS that really make microservices substantially quicker and easier to develop. Next slide. All right, so in summary, what we talked about so far is microservices are a paradigm shift in software development to allow us to deliver software quickly and cheaper. It's great because it can isolate failures from other parts of your system. So if one system goes down, that doesn't necessarily mean your entire application is down. And then finally, it's critical to incorporate DevOps and PaaS before you can even begin to be successful with microservices. So at this point, I want to thank you for your time, and I'm going to hand off to Buffy, who is going to talk about the business value of transforming and CI/CD. Thank you.
Thank you, Keith. So for this webinar, I was tasked with providing return on investment or business value of driving CI/CD transformation, specifically with platform as a service and microservices. Next slide, please. Thank you. So strategic vision and motivation. To understand or quantify the value, really you need to understand the need for transformation. So everybody is moving towards agile, but why? I mean, is it agility just for the sake of agility, or because it's the new cool SDLC methodology? No. You know, the reason we're moving towards agile is because in order for companies to compete in today's marketplace, you need to deliver product and technology changes to the customer immediately. You need to deliver in days, not months. You need to shift or change to meet the needs of your customers. You know, if companies or enterprises don't become agile, the companies that are agile will take huge chunks of market share from them. So it kind of just brings it really to a higher level of why we're even doing this. Classic examples, Amazon, HomeAway, Netflix. These are all companies that are agile and did take huge market share from companies that weren't as easy to shift with the needs of their companies. So when we talk about business value of agility or transforming, we're really talking about the value of survival. So platform as a service will provide you the foundation. DevOps then allows you for streamlining your automation. And microservices comes in as really increasing that speed by exponential factors. Really becoming agile, there are a lot of challenges. It needs a change in people, process, and tools. But I think the transformation or the business value around the transformation is really changing companies to the point of helping them survive what we call, you know, the digital era or digital disruption. Next slide, please. So continuous delivery in context. This really shows your, you know, mapping out your CI/CD maturity journey. So everyone begins at a different starting point. So from left to right, left being your CI and right being your CD. But make no mistake, anyone who's looking to be competitive in this digital marketplace is on this same journey. The goal at the beginning to bridge your CI/CD, going from left to right, moving from upstream to downstream through your SDLC. So making that one seamless pipeline from commit all the way to deploy deploy becomes critical. So once you begin to automate, once you begin to bridge from left to right, your dev cycle times decrease, your productivity increases. Then you can start moving up the chain, right? So moving up allows you to start scaling across the enterprise. So, and you need both, right? You need to first worry about the, you know, CI to CD, and then you need to scale that delivery or scale that automation up across the enterprise. So there are challenges of scaling, right? There's standardization, you know, team control, isolation, security, manageability. Is it worth it? Yes. We'll tell, you know, I'll give you some examples of customers that are on this journey and have had huge transformations in their company and their productivity. You know, but you know, once you, I think, actually, you can go to the next slide, please, and we'll look at some of the results of organizations that we've worked with. And as I said earlier, I was tasked with really, you know, giving you an ROI or real metrics around this transformation so that you can understand the actual dollar value of implementing platform as a service, DevOps, microservices. Honestly, it's likely impossible for me to make a general calculation about the value of securing your business's market share. I mean, what is the value of competitive advantage? What is the value of risk mitigation? What is the value of deploying faster at higher quality? You know, I can't always calculate those things for customers, but what we can calculate is the speed and efficiency gains, right? So all of these are helping with the ultimate goal of gaining that competitive advantage. So there's a lot of efficiency to be gained in simply automating manual tasks. right? The efficiency gains in the automation of manual tasks is time back on developers' plate. And on the slide here, I have just 3 examples of many where customers report back, their faster development life cycles, less staff time required. And so I think the goal when you're calculating the efficiency gains of structuring a standardized platform or platform as a service, increasing your speed through microservices. Really what you're doing is you're putting time back on your developer's plate, right? You're taking administrative tasks around, you're automating as much as possible, and you're putting that time back so that developers can spend time developing. And the microservices is allowing you to do things in parallel. Gartner reports that DevOps developers spend 22.5 hours per week, so that's half of their week, on non-design, non-coding tasks. That's administrative work, troubleshooting, environmental support. So if you're able to just put a smidgen, a portion of that time back on developers' plates, what does that look like in money back to companies? So automating just a portion of that, we estimate will recoup 1.5 FTE or 1.5 full-time employee per development team. And that is a very, that's just looking at automating a very small slice of the developer's time. So for any size company, that productivity gain can add up. So 1.5 FTE per team may not seem like a lot, but if you actually look at the dollar value of that, in a company of size 200 developers, that's about 400 million, that's about 4 million per year. In a company the size of about 500 users, that's about $10 million per year in efficiency gain. And just giving 1.5 FTE per team back. So the numbers can get really large. The actual dollar values can get very large. At CloudBees, we've worked with some of the largest Fortune 1000 companies, really, in all industries, to quantify this value. I'd like to put more of a general number up for you, but really every customer's transformation value is different. But definitely putting in place a repeatable, scalable, supported foundation and process is going to give you value, and that value is going to be huge. And some of the examples, like I said, are on the slide. So next slide, please. So just in summary, really agile delivery and process have become standard. Specifically targeting the need to deliver faster to customers. So whether you're a highly regulated insurance company, financial industry, or a fast-moving startup, you've likely started to adopt some agile approach. You're likely starting to approach onto your CI/CD maturity path. While agile is predominant approach to software delivery, it comes with a fair set of challenges associated with many fast-moving tasks, right? But proper DevOps enables you to transform. Enterprise-grade tooling and support allows you to transform at scale. And then microservices comes in and allows you to take that at an exponential growth. All with the goal of increasing your productivity and getting the business value of getting that competitive advantage. So I think foundation will be the key here. So in that, I will pass it over to Jeremy Davis from Red Hat, who will talk about microservices and platform as a service. You can go to the next slide. Thank you.
All right, thank you. All right, so I introduced myself earlier. I'm a principal solutions architect with Red Hat, specialized in our application development space, and I'm going to talk about microservices architectures and how that dovetails with platform as a service. If you have any questions, feel free to type them into chat. Don't be shy about interrupting, and then Max will just read those aloud in case I don't see them. All right, so just very quickly to level set, we're talking about Red Hat OpenShift, which is our platform as a service. Red Hat has no proprietary software. We're the world's leading provider of open source software solutions. all of our engineers commit code to community projects. We then take those projects and we run them through QA, we test them, we integrate them together, and we produce stable, supported products, with OpenShift being our platform as a service product that we're going to talk about this afternoon. Right, so before we get to OpenShift, I thought we'd hit a couple of topics on the way. So we start off a little bit with existential dread, and then give you a little bit of some recommended summer reading in case you've got some vacation or beach time remaining. And then we'll jump into a little bit of technical stuff with the state of the microservices practice, and then jump right into OpenShift and how it applies. So microservices, the phrase or the term was coined by this blog post from Martin Fowler and James Lewis. Martin Fowler is one of the most famous software architects. He's written any number of books, incredibly influential. And when this blog post came out, they were writing about patterns that they had seen in production with people that their consulting firm had worked with. And since this blog post in 2014, the idea has really taken the developer world by storm, right? But if we go back a little further, microservices start with the fear of death. And by that I mean they come out of an existential crisis. Earlier, Keith talked about Netflix and Twitter. Well, in 2008, Netflix began to experience outages. At one point, their back-end systems were down for an entire week. Obviously, it's not good if we can't process any business, for weeks on end. So the Twitter engineers, and there's some great conference talks that they've given about this. That you can find on YouTube. If you're interested in seeing their engineers talk about this. But Twitter went back to the Netflix went back to the drawing board, and they re-architected their systems into what today we call a microservices architecture. Now, as part of that process, they ended up doubling their headcount and doubling their infrastructure. So it wasn't without pain, right? This journey wasn't the easiest thing to implement, and implementing a microservices architecture has the potential to offer a lot of pitfalls or a lot of dangers. Eventually, of course, you realize tremendous increase in the velocity at which you can deploy and the ability that you can scale. Around the same time, Twitter, also in Silicon Valley Unicorn, experienced similar outages. You used to get the fail whale, right, when you would try to go and post something on Twitter or check your Twitter feed. Well, Twitter was also at the time one of the leading lights of the Ruby programming language. And they went back and they re-architected their systems. They were able to get their uptime, back to where it should be. And the technology press at the time noticed this and wrote a number of articles. And I remember reading how Twitter made Java cool again, right? Java saved the day from the younger programming language that was all the rage at the time. But what the press missed at the time, and part of that is because nobody really had a definition around it, was that Twitter had re-architected their systems to take advantage of microservices. So Java got all the credit, but one of the big enablers of their ability to scale was the fact that they implemented a microservices architecture. All right, so I thought I would give you a couple of recommendations about implementing a microservices architecture. If you have some time left this summer, we'll talk about doing some summer reading. One, there's a lot of great resources that you can download as PDFs on developers.redhat.com. These are all written by Red Hat guys, and they cover a lot of different topics from how to deal with data in a microservices architecture, which really deserves its own hours of talk around that subject itself. In terms of building, different patterns and different techniques of building microservices. But you don't have to take our word for any of this advice. But we talk about some of the other things that are out there as well. Because it's easy to take a look at, implementing microservices, breaking things apart, implementing lots of services. But there's a lot that goes into doing this. And as I mentioned earlier, there's also a lot of potential pain that's involved. Distributed systems and distributed programming is hard. And if you don't have a lot of the things that Buffy just talked about in terms of CI/CD and pipelines in place, it makes it very difficult. If you don't have agile development, that Keith was talking about earlier, it makes it very difficult to implement a microservices architecture. So these are both really good books. In fact, this phrase, speed and safety at scale, is my favorite definition of what microservices are about. Because it started off with scale, right? So Netflix and Twitter had to scale up because they were experiencing outages. But the real prize in most people's eyes is the speed with which you can get code into production. Code has no value until it's running in production and generating value for the business. So the faster that you can move code from development to production, the more value you're going to provide to the industry. And both of these books talk a lot about the cultural changes that have to be made in your organization to do this successfully, and how to be safe, how to increase that velocity, how to go from, as we mentioned, sometimes deploying maybe once a year or once a month to deploying every week and into deploying every day. Netflix, I think, talks about doing hundreds of deployments every single day. Another really good book, and this one is not as much about culture, but this one's really about the architectural patterns, is Building Microservices by Sam Newman. He's also with ThoughtWorks, the same company that Martin Fowler and James Lewis are with. And he has a lot of really great hands-on advice in this book about how to go about building your systems. And one of the points he makes is that microservices don't really require a specific programming language. They don't, specifically require a particular type of database or a particular type of runtimes. The protocols that the services use to talk to one another, people usually choose REST, but it's really not a requirement. You can choose other ways of communication. The one thing that he does say, though, that's required is a platform as a service. And in fact, he lists it as one of the common mistakes people make when implementing a microservices architecture is not using a platform as a service. And the reason for that is the flexibility and the agility that you get in your infrastructure with a PaaS. So we talked earlier about DevOps, right? And when you move from a monolithic culture and a monolithic application to a DevOps process where you have lots of teams doing different things in parallel at the same time, deploying in different ways, adding in new features in different ways, it brings in the potential for a lot of conflicts. Versioning becomes difficult. Doing deployments becomes a lot difficult. PaaS helps to smooth all of these things out. And all of these teams can be using different techniques, not just in their development or different languages in their development, but they're going to be using different deployment techniques. Some people might deploy 2 versions of a feature, and that way they can gather metrics around that feature and then make business decisions about whether it's driving the kind of change in their customer base or in their user base that they were hoping for. That's really kind of the golden goose, is the ability to respond faster to the business. And by having multiple different discrete parts and being able to test each of those parts independent of each other means that you can respond more quickly to the business drivers. But all these teams can be doing these at the same time. It puts a tremendous amount of pressure into the way that most organizations have traditionally deployed their software. So OpenShift is Red Hat's platform as a service. And you can sign up, or you can go to OpenShift.com and sign up. We have a free tier as well as paid tiers online, but most customers are looking at running this inside of their own data center or on top of say EC2 or another cloud provider. But what it's going to bring to the table for you is it's going to scale up, scale down. It's going to allow you to automatically scale up or scale down, to automatically deploy new versions of your software. The way it does this is it's built on Docker and Kubernetes. The Docker containers, I'm sure everybody on the call is familiar with Docker. It revolutionized the way people think about packaging up their applications. So it's similar to a VM, but it's a lot smaller, a lot lighter weight, and it's immutable, which brings some advantages over the management and maintenance of a life cycle around containers. The containers, in and of themselves, aren't necessarily easier to work with. As you begin to deploy lots of different parts, the orchestration of those containers becomes really the key piece inside of your system. And for this, OpenShift uses Kubernetes project, which was open sourced by Google. They open sourced their project that orchestrates containers inside of their own engine. Originally called Borg, it's part of the system of how they index the entire internet. We're now the #2 contributor to the Kubernetes project. Other things it does is it allows you to have fault tolerance, so that if something goes wrong, if a container that your application is running on does happen to run out of memory or have some other kind of problem and dies, it automatically scales your applications back up. You can set OpenShift to spin up containers across various data centers to achieve high availability. And it's self-healing, so if anything goes wrong, it will automatically set the environment back to the desired state. It does canary deployments by default, meaning It makes sure that the new version of an application or the new deployment of an application is healthy and running before it kills off the old one. So in the microservices world, the reason this is so important, and for this I will jump over into an example application. Now this example application is not very interesting. It's a pretty small website. And I mentioned my background. I used to write a lot of code. And this is an example website that the Red Hat developer team put together to illustrate some of the development techniques that you use inside of a microservices architecture. So there's a lot of low-level source code here. I'm not going to get into that today. If you do want to see the low-level source code, I am more than happy to talk about it. So shoot me an email after this, and we can absolutely follow up if you want to see some of the things going on in here. But this is a very simple little website, just a couple of different web pages. Now, if we look in the world of microservices architecture, this is the source code repository to make this couple of web pages. So instead of having one monolithic application, which would certainly serve our purpose for a half dozen web pages, we end up with lots and lots of different projects. Obviously, this creates management complexity and deployment complexity. So the way we address that is with OpenShift. I'm running this application here. The things we can do with OpenShift, for instance, is we can scale up our application. So this is scaling up a new Docker container, which we call a pod, and you see the phrase 2 pods there. So in this amount of time, I have deployed a second instance of this application. Inside my front end here, expand my screen a little bit to make sure you can see that. But all this is doing is tying in a machine name here. And if I refresh the results here, I get automatic scaling. So I go back and forth between these 2 pods, and I don't have to adjust. I don't have to adjust anything in my DNS. I don't have to make any adjustments, to my firewall. I didn't have to, change anything on the load balancer. All that is handled transparently under the covers. Why that's important is it allows you to get into some advanced techniques. Mentioned how code doesn't have any value until we get it into production. Well, so often feature changes get pushed out, or it's very difficult to make feature changes and respond to the business. Well, one of the things that microservices, one of the big promises of microservices, is it allows us to be able to try things out more efficiently. Let's come in here to this route. And edit this. I'll split traffic across multiple services, and we'll just leave it 50-50 here. And so now we see here I'm splitting all the traffic to this endpoint across 2 different services. So this, in a real-world application, all this is saying is aloha, right? Because this is just an example application. But in a real world, this might be a recommendation engine, or it might return search results. We could try out different algorithms for that, and we could gather metrics. And I don't mean metrics in the sense that guys like me, the technologists, typically talk about metrics. We could gather business metrics around this, and then make decisions, informed business decisions about whether or not we want to roll this feature out into production or whether we want to bring it back in. We can also adjust this down easily. We can come back and say a smaller percentages. And now we see here we've got a different percentage. But this level of flexibility would be extremely difficult. It's not impossible in the world of VMs. It's not even really impossible in the world of hardware. We could, of course, roll out a new server and rack it and get it set up and do all this. But the agility that you get with a PaaS is what's going to enable you to really make the changes at the speed that you need to make those kind of changes. All right, let's go back to slides. All right, now I mentioned I wasn't going to look at any code, but I am going to talk a little bit about some technology. So I mentioned that the phrase was coined 3 years ago in 2014, but people have been doing this for almost 10 years now. But ever since Fowler and Lewis blog post, there's really been an explosion in this kind of practice. And initially, a lot of the applications that were built were built from scratch. In fact, one of the things that Netflix talked about is essentially they created their own platforms of service that they ran on Amazon. A lot of the code that they used, they donated and became open source projects, and that's been utilized by lots of people that have already dived into this kind of architecture. But the state of but today we've kind of begun to realize that a lot of this code is infrastructure code, and it gets married inside of our application. It's not really something that we want to do. And so some of that kind of infrastructure code has begun being pulled outside of the application code. One way people have pulled some of this infrastructure out has found its way into what's called sidecar applications. So applications that you deploy along with the real service that you're standing up. And the sidecar handles a lot of the things like gathering metrics and health of the application. Well, even more than sidecars, one of the things we've seen recently is the concept of a service mesh. And this isn't unique to Red Hat or to OpenShift. We're contributing to the Istio project, which is us and Google, IBM, Lyft are all contributing to this project. Docker Enterprise implements something very similar to this. But the notion is that a lot of these kind of health checks and a lot of the metric sort of services gets pushed and built into the PaaS itself. And I'm mentioning this because as we're progressing, as the practice of microservices architectures and implementing microservices architectures has been progressing, the notion of running on the PaaS and the PaaS being a first-class citizen or a key to success is continuing as well. And a lot of the development in the space is now moving into the space of the platform as a service. So to sum up what I was talking about, we started off talking about how microservices came out of the need to scale, right? It came out of an existential crisis with scaling, meaning back-end systems weren't able to service the load or weren't able to do business. And it was a complicated solution that solves that problem. The real driver for most of the enterprise is speed and agility, and microservices deliver that. It allows you to tie specific features of your applications to business value and be able to get better metrics around that. But to do that, it requires a level of agility both inside your organization in terms of continuous integration and delivery and agile practices and DevOps, all of which is made easier by the agility that OpenShift or a platform of service is going to bring to your organization. All right, and with that, that concludes my part of the application. I hope we have some questions. I think we've got about 10 minutes left for questions. I'll turn it back over to Max at this point.
All right, thank you, Jeremy, and everyone. That was we do have some really great questions. That has been a really great session so far. I'm actually going to let Keith read them out as he is one of the tech guys, and I think he's going to really pick some really pertinent ones.
All right, great. Thank you, Max. One of the questions that came across is how do you build transactional microservices? So I think this is a great question, and I think one that highlights one of the problems that people highlight when they start thinking about this transition to microservices. How do you create transactional workload inside your application if it's distributed across 20 microservices? I think there's definitely a long answer to this. I'll try to give a short answer to this. If you want additional information, please definitely follow up with us later and we can talk more about it. But the short answer is that you generally want to think about transactional services inside the service itself. So when you're thinking about the bounds for a particular application, how you want to handle the transactions should be a part of that decision. So a great goal would be to try to create schemas that are encompassing of the transacted work that you need to do. However, that doesn't always work. And the reason is there may be transactions that are truly across different domains in your application. In that case, we have to stop thinking about it as transactions. We really need to start thinking about it as eventual consistency. So when you make an update to one particular data model and it has to update 3 other services, that will not be an instantaneous or a transacted process. You're going to have to communicate, whether it's via RPC or REST or some other mechanism to communicate between services. Again, eventual consistency is the key there, and that's true of any distributed system, which at its core, that's what a microservices architecture is. One of the other questions is it possible to migrate a monolithic app in phases, and how do you do that? So this is also another great question. I think to start this process is very difficult, as we've kind of talked about. So we've got to start thinking about it in We got to do the planning phase, figure out what kind of we want our SLAs to be, etc., how to decompose the application. But when you need to hit the ground running, you have to just start by creating a prototype. So you create a prototype of a microservice that you want to use in your application, and then ultimately you have to create an adapter in your monolith as well to communicate with that service so that you can have a communication layer between your microservice and your monolithic application. This is somewhat hard for people to swallow sometimes because then you're now writing code in a monolith that you're trying to get rid of. However, there's never going to be a case where you can be successful unless you have just started your application, where you can truly switch from monolithic application to I've rebuilt it as a microservice. You have to have these phases along the way where you start moving one service at a time, and you have to create those adapters in order to allow it to communicate with the rest of the application world. There are some other questions here. Let me just dig through them here. So this one looks like a good question. It says, large corporations don't know how to move or invest in moving their large IT departments to embracing microservices architecture. What are the tests that can be used within the enterprise to determine which monolithic application should be moved to microservices? I think this is a great question. I think ultimately the answer to this comes down to what is your most client-facing or business-critical application? And what are the challenges that you face with that? So if you look at what applications are causing the most problems because you're not able to deliver quickly, that should give you an indicator of which ones we should start thinking about for microservices, because ultimately that's the value that you need. You need to be delivering software more quickly, so you need to focus on the applications that require you to deliver more quickly. One question that was asked that I don't have a great answer to, and I think, Jeremy, you probably have a better idea of this, is what kind of application telemetry is captured and displayed in the OpenShift paths?
So yeah, I didn't fire up any of the kind of metric stuff that we have collected in there. So we capture all sorts of information around the environment, right? So you get a complete window into memory usage, into the health of the containers themselves. Some things that are traditionally very simple become very complex inside of a distributed environment like this, like logging. So all that gets aggregated for you together. We have projects that can alert based on deviations from the norm. And then there's also APIs that you can use to capture very application-specific health checks. The little example I had running, we've got some things built into those applications as part of the, I mentioned that was an example application to sort of teach and discuss some of the ways that you build a microservice, and part of that is building in health checks for your service, because there are certain kind of health checks which are kind of obvious, right? Are we running out of memory? It's pretty universal. If you're out of memory, it's very hard to get work done. But there are also health checks that are application specific, and those should be built in as part of the process when you are developing your services. Does that answer the question?
Yes, thanks, Jeremy. Yeah, people can't respond to us, so we have to assume. All right, so another question is, how do we define the isolation of microservice versus the isolation between conventional components? I think this is a tough question to answer without any context, and unfortunately one of the problems as we talk about microservices in general is that it's very hard to talk about them in general because it is ultimately use case specific. So defining your isolation level is somewhat hard to say without understanding the business case at hand. But in general, my rule of thumb is to think about a few different pieces. One is what is the feature that we're trying to define? Can it be isolated to its own domain if we're thinking about domain-driven design concepts? And if it can be, is it still small enough to be useful? And what I mean by that is if the domain is so large that you're just creating another monolithic application, that means the service is going to be too high. Another way to think about it, and this is somewhat easier to define when you're in your planning phase, is think about the service level agreements that you need to have for your services. So that's another good isolation boundary, because there are going to be some services that are business critical and need 5 nines, whereas there's going to be other that need maybe just 80% SLA. It's okay if it's down on the weekends. So in order to think about that service level agreement, like those are the units that you're deploying together. Meaning, if this machine has to be up 100% or 99.9999% of the time, then it needs to be on its own machine, whereas this other service doesn't, so it's fine for it to be on a different, I said machine, but I mean container, on a different container. Then that's another point where we can break that boundary. All right, we've got about 3 more minutes here, so I'm going to answer 1 or 2 more questions. This is a question that I did answer, but I'm interested in your opinion, Jeremy. What are the benefits of OpenShift versus Docker? You talked through some of the tooling, but what would be your general recommendation for people if you're trying to choose between Docker or OpenShift?
I guess I'm assuming you'll mean Docker Enterprise, as in the Docker Platform as a Service. Docker itself, we're using Docker containers, right? So if you mean choosing between Docker containers and OpenShift, you can choose both. There are differences between OpenShift and Docker Enterprise. The biggest difference is how we orchestrate the containers themselves, right? So the container itself is a Docker container using either Docker Enterprise or OpenShift. Our orchestration piece is built on Kubernetes, which is today Google and Red Hat are the largest contributors to Kubernetes. And Kubernetes has been gaining a lot of momentum inside the community. It's one of the fastest moving open source projects today. And Kubernetes is what I mentioned handles all of the orchestration between the containers. So when I click the button and I spun up another instance of that application, it handles the routing. If we want to talk really low-level tech, it essentially wraps that container with a virtual IP address and then load balances across various containers. As I mentioned, a lot of work, as I also discussed in sort of the 2.0 part, there's a lot of work that's going into Kubernetes itself around the concept of service mesh, on how we guarantee delivery, of how we do metrics. A lot of that's getting built inside of the Kubernetes project. And with Kubernetes, by the nature of having lots and lots of different companies contributing to it, is going to move at a faster pace than a single vendor solution, which is a lot of what Docker Enterprise uses. So they have their own, service mesh, they have their own orchestration piece. But the Docker format itself runs across both of those. So largely, one of the big advantages is just the breadth of the open source ecosystem that we're drawing from and pulling our components from. And then a lot of this, we've been in this game. So OpenShift has been around for about 6 years, going on 7 years now. And we retooled for Docker. We didn't originally use Docker containers. We have a lot of experience in this space, and so a lot of the features that have been pushed into that community have been coming from Red Hat. And so we're consistently creating, a more usable container based on, years of experience of doing this.
Okay, great. I think we've got time for just one more question, just because I think it's important and something we didn't highlight. The question is, can I develop microservices using the .NET Core framework? My company is using Microsoft technologies, or do I need to use Spring Boot for microservices development?
So
this is definitely, sorry, I have some thoughts, Jeremy, but feel free to jump in as well. I think one of the primary motivators for using microservices is the ability to develop in any tech stack that you want. And that means within the architecture itself. So you can have a Node framework, a Node service, you can have a .NET Core service, and you can have a Spring Boot service. One of the nice things about Spring Boot is just the ecosystem that comes with it. Netflix has contributed mountains of open source code to the Spring Boot framework, so that just kind of gives you a leg up. So that would be one reason to choose Spring Boot, but it's not critical, or sorry, it's not required that you use Spring Boot for microservices. You can use any tech stack that you choose.
And you can certainly run .NET Core on OpenShift. We are very friendly with Microsoft now, and they gave a demonstration at our developer conference earlier this year. You can run SQL Server on Red Hat Linux now, but .NET is a first-class language. And one of the advantages of developing microservices is that you can choose your technology stack. I mean, as I mentioned in the Building Microservices book, which again, I can't recommend enough. Great example of how to build, of how to develop this architecture. And one of the keys he says is, languages aren't really, there's not really a requirement on one particular language or one particular runtime. Spring Boot is absolutely what's really driven a lot of the interest, but there's lots of different runtimes you can use. One thing that's just beginning to sort of pop on the radar today are reactive microservices. But yes, you can absolutely use .NET on Red Hat OpenShift.
Awesome.
Right.
Thanks, Jeremy. All right, well, I think we are out of time here, so I'm going to hand off to Max for some final thoughts. But thank you, everyone, for your time and listening to us today.
Yes, thank you, everyone, for staying with us. I know we're a little past the hour, and thank you to our speakers for delivering a great presentation today. Just to remind everyone, we were recording this, so you'll be getting the recording and the slides in just a few days. On top of that, I'm going to be taking all the questions because I know that we got a lot we weren't able to answer, and we'll find something to do with them offline, and we'll get back to you. Beyond that, if any of you are going to be at Jenkins World in 2 weeks, feel free to come by the CloudBees, Red Hat, and Levvel booths and get some answers to these questions in person. Maybe you can see some demos. And beyond that, I hope to see you on our next webinar. Thanks, everyone.